I'm going to go through now an example of solving an annuity problem using your present value interest factor for an annuity table. And the example that I'm going to do is a loan on a home. And in this case, we're going to borrow $500,000. That is, you put your down payment down, you pay all your closing costs, whatever. The bank's going to give you $500,000. It's for 30 years, 4% a year. Now we're going to calculate annual payments. N's going to be 30. You and I both know that when you go get a home loan, these are monthly payments. 30-year loan, 360 payments, okay? We don't have 360 on our interest factor tables. The only reason we're not doing that. So when we get through learning, our calculator will do 360 and the like. That's fine. But right now, we're going to do annual payments on the loan. And with the answer that we get divided by 12, you'll probably be within about $15 of the right answer. Now, these are the terms of the loan. That is, how much I borrowed, for how long, and what's the cost of the loan, the interest that I'm going to have to pay on the loan. And the question then becomes, what's the payment on the loan? The payments on the loan are going to be the same every year for 30 years. That makes the payments an annuity. And if there's an annuity anywhere in the problem now, you have an annuity problem. Lots of students have a hard time determining whether or not it's a lump sum or an annuity problem. As a student, I always looked for the annuity. The payments on the loan, that's the annuity. I'm going to save, $5,000 a year for 30 years. That's an annuity. Always look for the annuity. The annuity, by the way, is not just in the question or in the prose that leads up to the question, but could be in the question itself. So you might read about this loan and think, geez, I don't see an annuity in there. But when the question is, what's the payments on the loan? The payments on the loan make it an annuity problem. So in this case, we have an annuity. And as I told you before, the first thing you should write down is your general equation. So the big dollar amount is equal to sum annuity times the appropriate interest factor. What's going to be the big dollar amount here? Well, remember that the value of the annuity is always a smaller dollar amount than the big dollar amount. So the payment on the loan isn't going to be $500,000 a year. It's going to be much smaller than that. So what's the big dollar amount here? Well, $500,000. And that's going to be equal to some annuity, and turns out that's what we're looking for here. We're looking for the value of the annuity. And if you multiply the annuity times the appropriate interest factor, which in this case is PVIFA. Why is that? Because you get the $500,000 today, and the annuity goes out into the future. So the annuity would have to work back to the present rather. Therefore, we use PVIFA, the big dollar amounts at the beginning of the annuity stream. And we're going to use PVIFA. Now, N, when you deal with annuities, N is always equal to the number of payments. So we're going to make one payment a year for 30 years, so N's 30. Those are 30 years. We want the annual interest rate, the yearly interest rate, that's 4% in this case. If you look up your PVIFA at 30 and 4%, you find 17.2920. Now, as a student, I want you to understand, you will always end up with one equation and one unknown. How do you solve for this? Well, you take 500,000 and divide it by 17.2920. And what you get is $28,915.11. So if you were making annual payments on this loan, that's what your annual payments would be. And if you made that payment every year for 30 years, you would pay a total to the bank of $867,453.16. This money that you pay to the bank now is comprised of two things, principal and interest. What's the principal on the loan? Well, that's how much you borrowed, $500,000. That means the interest on this loan over the 30 years, how much interest will you pay to the bank? $367,453.16. Go into any town, any city, one of the biggest buildings is always what? The bank building. How does a bank pay for all that brick and mortar? It rents money. What's the rent on money called? Interest.